Okay, so hey everyone. For the first part of the project, we followed the tutorial provided in order to build a machine learning model. We started off with three tests: VG1, VGG1, VGG2, and VGG3. And they can be um, seen in our files here. And then, so as you can see here, VGG1 took approximately 15 minutes to complete and had a prediction score of 66.8. VGG2, meanwhile, had a total runtime of approximately 25 minutes and had a prediction score of 71.54. And lastly, VGG3 had a total runtime of around 35 minutes and had a prediction score of 73.17. And since VGG3 had the best prediction score, it was chosen out of the three files to finish building the final model. There were a series of modifications made to VGG3, as it can be seen here. Where is it? As it can be seen here. And then finally, the model was finalized and run. And this was the longest run out of all of them. And as we can see from the, this was the resulting HTML file, this highlighted one. As we can see from the HTML file, this approximately took around about 4.6 hours to complete, the result of which is the H5 file for the final model, shown here. And that will be used in the final part of the project. And now I'll hand off to David, who will talk about question 4.2.
So for the second part of the project, 20 different images were harvested from Google Images according to the 10 available categories, which are the airplane, automobile, bird, cat, dog, deer, horse, frog, ship, and truck. So using Python, the images were converted to a 32 by 32 by 2 pixel resolution to make them harder to distinguish. In order to do this, the original .png file were imported by entering their name in the script shown right there and highlighted. The program then processes the image using PIL library to convert them to the 32 by 32 by 2 pixel format and saves these new pixelated images to a folder. And so if we run the code, we can see the image of the bird, and then we see the pixelated image right here. And now I will hand it over to Sebastian.
Finally, the final portion of this project performs both single image and multi-image processing. It takes user input at the beginning to determine which mode it's in. So if we select yes, we're going to go into the multi-image processing mode, and if we select no, we're going to go into single image processing mode. And then if an invalid entry is detected, an error message will display, and recursion will occur to return to the beginning of the function. As we can see right here, the main function is recursive. And then in order to test it, I'm just going to go ahead and hit some nonsense, and it'll go ahead and reset it there. So first we're going to try single image processing. So I'm going to go ahead and say no. And then I get a menu right here, in which case I can just choose. So for this one, I'll just go ahead and say 16 for horse. And as you can see here, here is the image prediction for the horse in percent. As you can see, it's 100% a horse. And then the class of the horse is shown right here. As you can see, it's 0, 1, 2, 3, 4, 5, 6, 7, as it is there. And there it has predicted correctly that this is a horse. So now it uses a try and accept block to catch our errors. So if I run it again, I'm going to go ahead and enable multi-image processing. So I'm going to say yes. And so now I can go ahead and enter a bunch of different things. So here I'm going to say 20. Here I can see that this is a truck. Again, here's my percentage. And here is the class, which is the truck. I'm going to go ahead and continue. So I'm going to go ahead and press another button. And so now I'm going to test this try accept block. So here is where the menu happens, or this is where all the selections happen. And then here I have a value error accept and an unbound local error accept to capture my errors. So basically, if I were to put a string or a character, you see here error, a non-integer value is entered. Please only enter a valid integer between 1 and 20. And then I'm going to go ahead and enter to continue. And then if I hit, say, 56, which is not in the range of this, our unbound local error will catch it. And again, this integer is out of the given range. Please only enter a valid integer between 1 and 0. And that is basically the program. If I hit quit, it quits, and we're outside again. And that is the demo.